So we'll start our first speaker. His name is Chee from Voyager, and he'll be introducing about the workings of a block explorer. Okay, so let's give him a big round of applause.
Hello, my name is Chee. I work in Dynamite, and Dynamite has a couple of projects, and I work in the Voyager team. For those who are new to the Starknet ecosystem, Voyager is a block explorer in Dynamite. How do I go to the next slide? How do I cue the next slide? Oh, we'll come to it. Okay. Oh yeah, I was in next and I hit next. Okay. So a TLDR for those who are not familiar with Block Explorer or who just want to have a description of what Block Explorer is. Block Explorer is a free tool, normally a free tool, to visualize the activity of in the blockchain, right? So a very simple use case. It's for us to view the transactions that we are in. For example, Alice will send some funds to the Bob. Alice would want to check if the funds have been sent, and Bob would want to check what to confirm if this balance has been increased. So all this can be done through a Block Explorer. It is very useful for newbies and pros like us. Everyone uses Block Explorer to quickly view into the transactions, to quickly view the activity of the blockchain. And the pros will probably use Block Explorer in a more sophisticated manner. They could probably check some, try to gain alpha, and that is something that's way beyond my scope, so we're not talking about it. But TLDR, essentially, Block Explorer is a very core component, a core infrastructure of the blockchain, and it's a must-have for an improved user UX. I quickly attach how it looks like, how this transaction looks like for Voyager. Just like how you would see in this scan, we have that in Voyager as well. You have the transaction hash and one other details. So obviously you can scroll down, you have more details, but I'm not going to use because it's a bit too long. At least. So people have been coming up to me and say that, okay, Block Explorer, it seems pretty straightforward to do, very easy. You just have to create a page, include details, and so on and so forth. So I've been asked and told and accused that it's very easy to do, and they say they can do a better job than the people that do Block Explorer. So we'll see, along with my slides, if it's actually easy or hard, and I will decide. Next slide, please. There are definitely unseen difficulties, so it's very easy to say, it's easy, but when you actually start doing it, there are a couple of things that will actually pop up. So one of the things is that you can't need to add feature really fast. What I mean by that is that, for example, let's say you have back in the years where NFT didn't exist, and suddenly you have NFTs because NFTs say yes, it's sensible. So Block Explorer have to add NFT support quickly. If they don't, either they lose out to competition, or users will have decreased user experience when browsing Block Explorer. So the Block Explorer developers are always fighting to add new features, always fighting to see what can be added fast. So imagine something pop up tomorrow and we have to be as fast as we can to iterate and to quickly release the product. So that is something that is really challenging. Infra is something that people don't normally think of. But imagine, especially when there is a mint or an airdrop or whatever crazy activity that's going on. The Block Explorer is normally being visited many times by one user, and there are many users who are doing the same thing. So if you imagine millions of views or even from all around the world. So the infrastructure behind the Block Explorer has to be able to cater for such traffic. So that itself is not something that people normally don't consider. But when running, you notice, start. What should we do? Should we stay up or not? So there are a lot of firefighting going on behind the scenes that people will not see. Breaking changes, especially in the Starknet ecosystem. So for those early adopters of Starknet, you probably have seen that Starknet has changes over the months and weeks. That means it changes very often. For example, back then there was this concept of Cairo Zero, where there's a certain way of running contract, and then they just scrap this entire way, deprecate it, introduce Cairo 1, where there's a new way of running contracts. So changes like that are not foreign for Starknet, and as a Block Explorer, we need to be able to be fast to capture these changes, or if not, either we have a non-functioning Block Explorer because the feature is to break all of stuff, or we display incorrect information, right? And one thing that we have to keep in mind when it comes to protocol changes is that we also have to maintain for some sort of backwards compatibility. Because let's say if the changes are applied on block 5, what happens to block 0 to 4, which is old changes. So we also have to maintain the code to get for old logics. So you can imagine that the code can bloated up over time, but there is really no choice to do it. You have to be very careful to consider, and those old stuff are normally not included in docs, so you have to document nicely the code or document nicely the internal resources, and those are very, very easy to handle, especially on Starknet, which I actually dislike. And worst of all is that you actually have to know and be aware of all the changes in the network. Not only do you have to worry about protocol changes, you have to worry about new release on all fronts, such as maybe there's a new DeFi protocol and you need to implement like a new tracking page for the new DeFi protocol, for example. Basically, there's no one area that we can focus on. We have to know areas in various space in the blockchain. Next slide, please. So yeah, there you go. I described my difficulty in developing a block explorer. So without further ado, I think most of you probably interested, like how to build a block explorer. So let's go. Number one, to access data from block explorer, you need to know you need to know the RPC. So RPC is your friend to access the network, and RPC is your gateway to get information from the blockchain. Over here, I have included two very commonly used RPC. So most blockchain, such as Ethereum, such as Starknet as well, such as, I don't know, whatever chain, I don't know what. You have to get block details. That means this RPC will return you with the block information. And more importantly, you want to know what are the list of transactions that are available in the block. So this information, this RPC will generally return you the list of transaction hashes. And then you have get transaction detail, which you then call to get more information of what the transaction is about. Right? So for example, if there is a transfer transaction in Starknet, it will be an invoke function. But of course, there are various types of transactions in Starknet, such as declare, deploy account, and deploy, which has been deprecated, and we still need to handle those, because if not, should we receive from scratch, sometimes we need to, it will break our explorer. So depending on the type of transaction, there is a need to handle the transaction differently. Like declare, we know that declare is a declaring new class. We need to, for example, perform this X logic. Invoke is calling a function. We need to call this A logic, and so on and so forth. So yeah, knowing that is pretty important. Next slide. So with those two RPC, what can we do? This is a page that lists out all the blocks. We can list out all the blocks when we have that block details. We know basic information such as how many transactions are there. It's very blurry. I hope everyone can see. The number of events and how old. And this is a very general page that you can see in most explorers. Next page, please. And show transaction details, which show you like what exactly happens in transaction. Over here, there's a call data part where it shows you what functions are being called as well as the primary and passive. All these can be obtained via the get transaction and receive RPC endpoint. Regardless of if it's Starknet or Ethereum, it should be around the same. Please. So one thing that is pretty interesting for transactions are events. Okay, sharp now. One thing that comes with transactions are events. And events are low-key, super important. Let me give you an example. When we are implementing, for example, ERC20, and ERC20 comes with a certain set of standards you have to comply to, not to be considered ERC20. There's this transfer event function that it will be emitted whenever the transfer function is called, right? So Block Explorer utilizes this transfer function. We detect that transfer function, and then we are able to then show details like, okay, for example, this guy has minted this amount and so on and so forth. In this case, it's a main event, and so that's how we're able to know that, okay, it's a main event, it's a transfer event, and so on and so forth, and we put it in the transaction detail page. And you can see that this really improves the user experience. If not, you need to actually go to the transaction and decode everything on your own, because they're all hexes. So this is more improved UI and UX, and it's a much later improvement, right? Okay, next slide please. So what happened after we have gotten the data from the RPC? We need to store it somewhere. So for those who know about DB, you know that there are two types of DB, SQL and NoSQL. Some people are fans of MongoDB and want to do everything Mongo, you know. It's pretty cool, MongoDB, but in what I feel personally, my take is that MongoDB is not too practical when it comes to Block Explorer. SQL is definitely not our choice. Let me tell you why. Because SQL, we know that SQL's strength is to be able to join and filter easily, and to be able to develop things faster, like add a new feature. We definitely do not want to restore everything in a new NoSQL format, because if you want to, for example, add a new filter, you have to probably reindex everything in MongoDB. But with SQL, you can just easily query by where and filter by column. And these are the features that it could be slow in performance, right? But it improves the iteration speed of the Block Explorer. Yeah, next slide please. Yeah, and also we need to think of how do we store the data, so and make sure that it makes sense. So definitely, I've shown that we have gotten the block details from the block detail RPC. So definitely there will be a blocks table that contains the block number, block hash, and so on and so forth. And we have the transaction table from the transaction detail page. And we probably will need to include a column called block number, because most of the time, or like almost all the time, when you go into the transaction page, you probably want to display the timestamp. And to get a timestamp, you have to join the block number with the block table. And yeah, timestamp is one example as to why we need to join the block table to get a number, to get a timestamp. And we are able to show that, this transaction is like 5 days ago and so on and so forth. So another example that we give is like storing the transaction hash in the events table, because we often want to link back. We want to know like which transaction is responsible for this event and so on and so forth. So with that, you can think of like, okay, we need to be flexible. We need to be able to connect the different tables. So this requires a bit of experience, a bit of understanding of what we want to achieve, and a bit of design. Next slide, please. Excuse me. And the hardest part, I think, is how do we design the page, the final page, in such a way that it's nice and it's also user-friendly and doesn't confuse users. Because as I mentioned, users of Block Explorer varies from beginner to pro. So imagine if I design the page to be very sophisticated, and beginner will be like, what on earth is this page? There's so many details, right? And beginners don't really want, don't really care. So we have to somehow strike a balance between that. So that it's very hard. So maybe we, I don't know, have a drop down or something like that, or maybe we allow advanced mode or something like that, right? So these are the design considerations that we often have to think about as the features of Block Explorer grow. And we also need to think of like what kind of what data information is useful for the users. And one thing that I have shown here is the events types. So whenever an event is emitted, you have the parameters, and they often have different types. So in this case, we decided that it makes a lot of sense to show the type as contract address. It's a long contract address, and this is the contract address. And integer is this number. And we also decided that it's nice that we allow users to be able to like tab around the text back and text selection. It depends on what you want. So this is our design choice. If you don't like it, let me know. You probably need something to fix it. So there you go. So now that I've talked about like how the basic inner workings of Block Explorer, what's going to happen next? People have been asking when open source Voyager, and it's happening very soon. There's no date yet. We're trying to find someone to actually lead it. But when it's ready, it will definitely be announced on these two little channels, Xerox Voyager Online and Nethermind Star. So we definitely welcome open source contributors to come and contribute to the project. And with this basic knowledge and use, it will be helpful to write some code in our open source project. And then everyone can have an open source Explorer by Voyager. Next slide, please. And I would like to remind everyone that Dynamite is constantly hiring, is now aggressive hiring for full-time and interns, especially APAC region. So we are in APAC region, so all of you are definitely who wants to work in Dynamite, regardless of you being exporting or not. Because Dynamite, we do a wide range of scope. We are involved in the auditing industry, we are involved in client development, for those who are familiar with Dynamite clients, right? Research, field of research, CK, research as well. We have tons of, very involved in tons of areas across the Web3 space. So definitely do give us a check at metamine.io/open-roles and apply if you like. And internship program is pretty interesting. It's a 3 months paid internship. We had like around 100 interns last year, and we would like to ramp up to 200 interns this year. So for those who are looking for a way to get into space, who are worried that you may not be good enough for a full-time job, then probably internship is something that you can consider. It's going to be paid, so it's going to be nice. So with that, I would like to thank everyone for listening and have a lot of questions. Thank you.